Alright students, here we go. On the day that this was assigned, I'm going to produce the video. So here we're asked to find the inverse of each function. Now, there are 3 steps that you must follow for every one of these problems. The first step is you must actually find what you think is the inverse. And I'll show you how to do that. So that's step 1, find the inverse. Step 2, determine if the inverse is a function. Okay, I'll show you how to do that. Step 3, determine if the thing that you found that you think is the inverse is actually the inverse. That's called validation. So first we find what we think is the inverse, we check to see if it's a function, and then we validate that it is in fact the inverse function of the original function. So let's begin that process. There is not enough space, even though I added additional space here, to do all the writing that you need to do. So we're going to have to use some blank paper, okay? So you need blank paper, and then we'll just put the solution here, and then all of your work will be on some additional paper. So g of x equals negative 4x plus 5. Let's move over here and write 1. G of x equals negative 4x plus 5. So remember, the first step is to find what you think is the inverse. And so here are the steps to do that. Step number 1 is to replace g of x with y. Okay, so let's do that. Instead of g of x equals negative 4x plus 5, we have y equals negative 4x plus 5. Now the next step is to swap x and y. Okay, so instead of y equals negative 4x plus 5, I'm going to write x equals negative 4y plus 5. Okay, now the final step, solve for y. And then I like to put it on the left, okay? We want it to say y equals. So you want the y to end up on the left side of the equal sign. So this is the algebra part. I would start by adding 4y to both sides. Thus we have 4y plus x equals 5. Okay. And then we would subtract x from both sides. Giving us 4y equals, we want to lead with our linear term. So negative, and I like to put 1x, it's going to become important later, plus 5. And we want this to end up in slope-intercept form. As a quick reminder, slope-intercept form is y equals some slope x plus b. Okay, m is the slope, b is the y-intercept. Right, that's what we're going for. So the final step here algebraically is to divide everything by 4. And that cancels these 4's here, giving us y equals negative 1x plus 5 over 4. Or you could write an equivalent expression, y equals negative 1/4 x plus 5/4. Now that would be true slope-intercept form. However, what we are going to do, and actually, so we needed to do this step to do the function analysis, but that third step, validating whether or not this thing that we think is the inverse is actually the inverse, this form with the huge denominator, or the huge fraction bar and 4 in the denominator, that's going to be the form we want to use. And that will become obvious here in a minute, just a minute. But first, let's determine if this is a function. So now, determine if function. Okay. Now there's two ways of doing this. Way number one is to graph it. That's the easiest way. And then you perform that vertical line test. If it fails the vertical line test, it's not a function. But there's an easier way. Okay? Just look at the y value. Does that y have any exponents at all? No. Okay? So because y has no exponents, for every y value, there will be a unique x value. In other words, you can't nothing that you put in here for y will result in the same x. All right. I'll just demonstrate that a couple of times so you see what I'm getting at. We'll try 0 for y, all right? Okay, so 0 equals negative 1 over 4x plus 5 over 4. And so if I wanted to solve for x, okay, I would subtract 5 over 4 from both sides. And I would have negative 5 over 4 equals negative 1 over 4x. And then to get rid of the negative 1 over 4, I would multiply by the reciprocal, which would be negative 4 over 1 on both sides. And these cancel, leaving behind a negative 1. And so I have negative 1 times negative 5 gives me 5, equal to, remember these cancel each other out, leaving behind 5 equals x. Okay? So let's, just try another x value, right? Let's try 1, or let's try another y value rather. Let's try where instead of we replace the y with a 0, let's replace the y with a 1 and solve for x again. So let's say 1 equals negative 1 over 4x plus 5 over 4. Subtract 5/4 from both sides. And you have negative 5 over 4, and if you'll permit me, I'm going to reinterpret this 1 to be 4/4 plus 4 over 4 equals negative 1 over 4x. Okay, so let's simplify this. That gives me negative 1 over 4 equal to negative 1 over 4x. And now I'll multiply by the reciprocal, which is going to be negative 4 over 1. And you're going to notice that these 4's cancel, these cancel, and you're left behind with a negative 1 times a negative 1, which is just 1. So 1 equals x. And what we're observing here is that I'm not getting the same x value, right? The x value doesn't appear to be repeating. Now this could go on forever, right? We could just keep trying values. But generally speaking, when you have a linear equation like this, this is a function, okay? You can anticipate this will be a function. And if you were to graph this function, which you could do in just an instant without really even trying very hard, it's not a difficult process. You can graph this. It doesn't have to be a perfect model here. So there's y and there's x. We have a y-intercept at 5/4. So let's just call that right here. And my rise over run is down 1 over 4 to the right. Right? So it's just like down 1 over 1, 2, 3, 4. Okay, so at some point right there. So my line would look, very, very crudely speaking, something like this. Okay. And we see that does not violate the vertical line test, so it's a function. So now we've determined that the thing that we think is the inverse is a function. Okay. So now we're going to propose something. We're not done yet. We're making a proposition. So here is our proposal. Okay, we are proposing that y equals negative 1x plus 5 over 4. Y equals negative 1x plus 5 over 4. Is the inverse, okay? Is the inverse function of g of x. Okay? So we can write this in function notation. Inverse function notation. So now we can write our equation using inverse function notation. Okay, so here's that inverse function notation. If g of x equals negative 4x plus 5, we propose g inverse x equals negative 1x plus 5 over 4. Okay, so I just want to focus in on this notation. It looks like I wrote g raised to the power of -1 of x, but we don't read it that way. The way we read this is g inverse x or g inverse of x. Okay? So we never say g to the -1 of x. So you just get this in your head that this notation means g inverse x. Like this means g of x. This is g inverse of x. All right? Now you're about to find out why I keep using this form of the equation instead of the slope-intercept form of the equation of the line. Okay, because now we're going to move on to validation. Okay, validation is a big deal when you're dealing with inverse functions. Okay, so let's move on now to validation. Okay, we have to prove okay? We must prove something. We must prove that g of x and g inverse of x are really inverses. Okay? Now the question is, how do you do that? All right? Well, you use the verification rule. Somebody might ask, what's the verification rule? Here's the rule. Okay? If g of f of x equals f of g of x equals x, then g of x and f of x are inverse functions. Okay. So I hear some people saying, where did f of x come from? This whole equation is about g of x. F was nowhere to be found. You're right. So we're going to begin the process of validation now. And the very first step is to assign f of x to g inverse of x. All right? So you're just renaming it, right? You're just temporarily renaming g inverse x f of x. Okay? So, let's continue. Step 2. Write g inverse x equals what we think it equals, -1x plus 5 over 4. -1x plus 5 over 4. As f of x equals -1x plus 5 over 4. Okay? Okay, so over 4, right? So now we've assigned g inverse x as f of x. And so now we're ready to perform this validation rule. So first, what we're going to do is evaluate g of f of x. And we're going to hope that it evaluates out to x. Okay, so let's make that step 3. We are going to evaluate g of f of x. Okay, and then I'm going to put out here and hope it equals x, right? That would be really great news. So let's go ahead and do that. I'm going to switch out of green because we're going to be doing some math here. So let's begin by writing g of f of x equals, and now what we need to do is look at the original function, g of x. So this is the framework. G of x is negative 4x plus 5. All right, so let's go down to here and write negative 4. Okay, and now what I'm going to do is I'm going to do an open parentheses. Remember, it was negative 4x plus 5. I'm going to do an open parentheses and put in here f of x, because I'm evaluating the g function at the function f of x. Okay, so it's kind of weird. And then this was plus 5. All right, and so now we're ready to substitute what f of x equals inside here. And this is when you're going to find out why I kept insisting that we leave the equation in this form. It's going to become super obvious why. So once again, write g of f of x equals negative 4. Now put a big open parentheses here because we've got a huge fraction. And let's write that whole fraction in there. Negative 1x plus 5. Use a straight edge, please. I want straight lines. No freehanding this fraction bar over 4. Do you already see why I wanted you to leave it like this? So now we close the parentheses off, and then we don't forget about this plus 5. Okay? So now it's obvious, right, why we wanted to leave it in this form, because look, I can just cancel the 4's. Because this was a numerator, and this was a denominator. So I can cancel the numerators and the denominators. What's really important to remember when you do this is that because there is a negative symbol right here, I didn't cancel the negative symbol. Okay, so what's going to be left behind is a negative 1. All right, so we're not out of the woods yet. We can't get rid of these parentheses just yet. So let's continue. G of f of x equals negative 1, open parentheses, negative 1x plus 5, close parentheses, plus 5. And now we're going to perform the distributive property and distribute that negative 1 to both terms inside the parentheses. Now, remember what I told you about distributing negative 1. When you multiply a negative 1, all that you do is change the signs of everything that you're distributing that negative 1 to. Okay? So all negatives become positive and all positive become negative. So g of f of x equals, we don't need the parentheses anymore. Negative 1 times negative 1 is positive 1, so we don't even really need to write 1x. We can just write x And then negative 1 times positive 5 is negative 5. And then we don't forget that plus 5. Plus 5. Okay. And now here's the wonderful moment. Negative 5 plus 5 is 0. So I write g of f of x equals x plus 0. Therefore, g of f of x equals x. And this is just amazing, because what we've done is half of the validation. Look, we found that g of f of x equals x. So we found this. All right? And that's big news. We're halfway there. Now we just have to do the opposite. F of g of x, let's hope, equals x as well. Both conditions must be satisfied in order for the original function and the thing that we propose as the inverse function are in fact inverse functions. Okay? So now that we've done g of f of x, we're going to do step 4 of this validation process, which I'll go ahead and write in green since that's kind of what we've been doing. Step 4. Evaluate f of g of x, and hope it equals x. All right? That's what we're really hoping for. Because that if we do this and it does simplify down to x, then we're done. We've validated it. We've proven it beyond any doubt. And we can confidently state that the g inverse x function that we found is in fact the inverse of g of x. But we can't state that yet because we haven't actually done this. So let's do it. Ready? Switch back to black. So now we're doing f of g of x. Okay. So what we're going to use for this is this framework right here. F of x equals negative 1x plus 5 over 4. Where you see this x right here, we're going to replace with open parentheses g of x, close parentheses. And then we'll substitute in what g of x is. So let's go here and write, just want to make sure I get it right, negative 1, open parentheses, g of x, close parentheses, plus 5 over 4. Okay, here we go. Negative 1, open parentheses, and then I'm going to put g of x in here, just as a little placeholder, close parentheses, and then plus 5 over 4. Plus 5, okay, please use a straight edge, over 4. And now we're going to substitute what g of x is inside this parentheses. Now, that was given to us at the beginning of the problem. That was actually what we were given, okay? So let's go back to the beginning of the problem. G of x is negative 4x plus 5. So we're just going to substitute in negative 4x plus 5 right there. So f of g of x equals negative 1, open parentheses, negative 4x plus 5, close parentheses. And now we need to put plus 5. We can't forget about this plus 5 because that was part of the f of x function. And then we put that whole thing over 4. Okay, we're almost done. Okay, so now we are going to distribute that -1 to both terms inside the parentheses. So we have f of g of x equal to, and remember this just changes the signs, so we can get rid of the parentheses now. We just have -1 times -4 gives us positive 4x. And then -1 times positive 5 is -5, -5. Bring in that plus 5. Fraction bar. Over 4. Okay. Now, it's tempting to just do a whole bunch of stuff in this one step. And I don't want you to do that. I want you to do one step at a time. So one step per line. So the step that I'd like to do here is just notice that -5 plus 5 is 0. And so we're going to write f of g of x equals 4x fraction bar over 4. And now we can cancel these 4's. And remember, that just leaves behind 1's, and we don't have to write those. So we have done it, folks. F of g of x does indeed equal x. Okay, so this is amazing. We've done it. So we've proved that g of f of x equals x, and that f of g of x also equals x, thus satisfying both of the conditions of this rule. G of f of x equals x, yes. F of g of x equals x, yes. So since both of these things equal x, they also equal each other. Okay? And as a result, g of x and f of x are inverse functions. So we're going to write that as a conclusion. Okay? So this whole thing is like an essay written using mathematical symbols. So it had an introduction, a body, and a conclusion. So here's our conclusion. Okay? And I'd really like you to write this out, okay? Because writing it out will teach you to think mathematically. So let's write this out. Since f of g of x equals x, and g of f of x equals x, then we may conclude both f of x and g of x are inverse functions of one another. Right? Kind of written out in plain English. So there's a final step here. So your final step is to convert / reassign f of x I'm going to use an arrow here to that g inverse x notation. Okay? And here's the thing that you're going to end up writing in your answer area. And now we get to use this fancy. So we're going to write this out. If f of x equals, and what did it equal? Negative 1x plus 5 over 4. If f of x equals negative 1x plus 5 over 4, and f of x equals g inverse x, then g inverse x equals negative 1x plus 5 over 4. Okay, now for the purposes of writing it down as an answer, I would recommend writing this in slope-intercept form, where you put the 4 underneath each term of the numerator. Okay, like this. Thus, g inverse x equals negative 1 over 4x plus 5 over 4. Okay, and that is your solution. So g inverse x equals negative 1/4 x plus 5/4. Okay? Negative 1/4 x plus 5/4. Okay, let's go back to number 1. And we're going to write g inverse x equals negative 1 over 4 x plus 5 over 4. And we've completed number 1. Now, because of the time, I'm going to conclude this video so I can get at least this video posted tonight, so you have something to work with, right? Because exactly the same process applies for the rest of the problems. So let me conclude there. And then my promise to you was I was going to do the odds, right? So I've still got more work to do, but it's 7:11 p.m. and I'm still at the school. I was here last night until 9:45, so I'd like to get home a little bit earlier tonight. So the next time code you see in the combined video might be 2:30 in the morning when I wake up. But we'll stop here for now, and I'll get this video posted so you've got something to work with tonight if you want to start on your homework. Guys, I just want to conclude by thanking you. And as always, before we stop the video, we always take a look at our work. Because it's fun, right? To sort of just look at what we accomplished. Please strive for neatness like this. Okay? And there's a reason for it. It's like, if, for example, if you were to get this wrong, okay, somehow, somewhere you messed up, it would be trivial for me to go through the steps one by one and see all of your internal brains work, because you basically wrote, well, if you write out every single step like we did, then what occurred in your brain is written down on the paper, and it will be very easy to identify where you made your mistake if you make one, okay? Like if you found out on number 1 that you couldn't get this to equal x, but you'd written out all the steps really neatly like this, then it'd be very simple to kind of just scroll through your problem and say, right here, you forgot to distribute the negative or whatever it is. So that's why I'm insisting on this kind of neatness and rigor, okay? So just to say it again, I appreciate your attention. With mathematics at this level, it's so important that we establish these strong foundations, because it only gets harder from here. And if you try to just jump through all the hoops and do it real fast, then you're not building a solid foundation. And so you're not doing yourself any favors by rushing. I am deeply opposed to the timetable, where we have to sort of move so quickly through topic to topic to topic, because sometimes we need to let this sink in, and we need to go really slow. And then once you get really good at it, you can go super fast. But in the beginning, you need to go really slow. So please take your time and just don't rush. You see, in this video, I did not rush. And it helps me avoid mistakes when I don't rush. Every time I try to rush through a problem, I always make some silly mistake, and then it's both embarrassing and time-consuming to go back and find that was a silly mistake, caused me to get the problem wrong, okay? So please take your time, and I do appreciate your attention. Thank you so much for watching.